questions. That was my mistake. I'm sorry for that. So I'll not evaluate those questions. Let me just tell you this one. First of all, the fourth one. Actually, I put the minus both in numerator and denominator.
Yes, I was gonna ask, but
yeah, so you could have asked, right? Otherwise, its answer is 1. You can see its answer is 1, right? It's the same thing in the numerator and denominator. So actually, it was supposed to be positive in the numerator and negative. So that was my writing error. So I've omitted this question. And one more mistake I did at question number 10, right? Actually, I gave you this, that sine A minus 2 sine square A and divided by 2 cos square A and minus of cos A, right? So I think you all were stuck in this question. It was supposed to be cube here. So that's another mistake. So I have omitted these 2 questions from the test. I'm not evaluating it. Okay, so question number 12. Should I discuss 12 now?
yeah.
Okay, 1 plus cos theta plus sine theta. See, it's not that tough. You just have to look at it very carefully. And this you have to show equal to 1 plus sine theta upon cos theta, right? Yes, Abdullah?
Yes,
I think you are also stuck in this. See, first of all, observe it very carefully. You have 1 plus cos theta in the numerator and then 1 plus cos theta in the denominator also. So can you say this is a plus b upon a minus b kind of thing?
Yeah.
Yes.
Yes, ma'am.
So what we will do it, we will rationalize the denominator, right? So I'm just doing it directly. Like you can do one thing here, that 1 plus cos theta. And so obviously with the positive sign, right? And then 1 plus cos theta and plus sine theta. So I can do this.
Yes, ma'am.
Yeah, Martin, I mean, you can just look at it carefully.
Yeah, I understand.
Okay. So I'm rationalizing it. Now what will it become? So it will become in the numerator, I'll get 1 plus cos theta and then plus of sine theta whole square, right?
Yes, ma'am.
So I can just combine the 2 terms. There's no problem. Both are positive. And in the denominator, now you can see I have a minus b into a plus b kind of thing, right?
Yeah.
So it will become a square minus b square. That's the identity we know, right? So
Yes,
it will become 1 plus cos theta whole square and minus of sine square theta. Is this okay?
Yeah.
Okay. Now you open the bracket in the numerator. So in the numerator, now I have a plus b whole square. So when you have a plus b whole square, how do you open this bracket?
A square plus b square minus plus 2ab.
Very good. So that's the identity we will use, right? So it will become 1 plus cos theta whole square plus b square, that means sine square theta, plus 2ab, that means 2 into 1 plus cos theta into sine theta. All right?
Yes, ma'am.
Okay. Now you come back to the denominator. Again, I'll open this bracket, 1 plus cos theta whole square, that means a plus b whole square. So that becomes a square, right? Plus b square and plus 2ab. So 2 into cos theta, right?
Yes, ma'am.
Or into 1, like if you want to write 2 into 1 into cos theta and 1 square. Okay, and then minus of sine square theta. Okay. Now one more time I have to open the bracket in the numerator. Again, I have 1 plus cos theta whole square, right? So one by one, I'm opening all the brackets. Now this bracket I'll open. So it will again 1 square plus cos square theta and plus 2 cos theta, right? A plus b whole square. Then you have sine square theta and then plus you have this 2 into 1 plus cos theta into sine theta, right? And now your denominator, so it is 1 plus cos square theta and plus 2 cos theta. And again, I can write this sine square theta as 1 minus cos square theta from identity 1.
Yes, ma'am.
right, Abdullah?
Yes, ma'am.
Okay. Now look at the numerator. So you have cos square theta and plus sine square theta. This will become 1, right? Okay.
Yeah.
Okay. So, and 1 you have here. So 1 plus 1, 2. All right.
Yes,
Then
ma'am.
2 plus 2 cos theta, and then 2 into 1 plus cos theta into sine theta. So this is left now. Now in the numerator, what will I get now? Okay, let's open the bracket. First of all, let's see 1 plus cos square theta plus 2 cos theta and then minus 1 and plus cos square theta. All right.
Yeah.
Okay. Now this 1 and 1 will cancel out. Okay. Right. And then you have 2 plus I can do one thing, like from the first 2 terms, I can take 2 common. So I'll get 1 plus cos theta. Any problem?
No, ma'am.
No, ma'am.
Plus 2 into 1 plus cos theta and then into sine theta I have. And now divided by, so cos square theta plus cos square theta. So that means I have 2 cos square theta now, right? So it will become 2 cos theta plus 2 cos square theta. All right.
Yes,
So I'm
ma'am.
doing it here now. So you can see in the numerator, I can take 1 plus cos theta common because it is there in both the terms.
Yeah.
And I'm left with 2 plus 2 sine theta. Clear? And then divided by, again, I can take I can take 2 cos theta common. And then I'll have 1 plus cos theta, right? Now this 1 plus cos theta, 1 plus cos theta, the bracket will cancel out. Again, you can take this 2 common. So you have 1 plus sine theta and divided by 2 cos theta. Now 2 will get cancelled out. So you will have 1 plus sine theta divided by cos theta, and that's your RHS. See, this was not tough. I mean, you just had to look at it very carefully. Right?
Yes, ma'am.
Okay, any other question you want to ask me?
The fourth one, but then 1 minute after I.
Okay, you can write it down. This type of questions, I mean, they usually come. Yes, Abdullah, any particular question you want to discuss here?
No, ma'am.
Okay. Martin, how many exercises you completed from trigonometry with me?
Ma'am,
Sorry, a bit louder.
let me check, ma'am.
So we were, I think, trigonometric ratios we have done with you. And then that exercise which has sine 30, sine 45 angles, etc. that we have done, right?
Yeah.
Okay, and the next one, third one, complementary angles.
I think we are in 8.3.
Yeah, we were doing 8.3. So the fourth one is actually based on trigonometric identities, Martin. So for the time being, you can just note down 3 identities.
All right.
So I'll be using them again and again. And the questions, I'll ask the office to share the videos with you, right? Which you have missed 2-3 classes.
Okay.
So, I mean, you just go through the videos, and in case you have any confusion, then we can arrange some time and discuss, okay? So from exercise 8.3 until the end, I'll ask the office to share the videos with you. So these are the 3 identities, Martin. These are called trigonometric identities. That is sine square theta plus cos square theta is equal to 1, right? And the second one is 1 plus tan square theta is equal to sec square theta. And the third one, 1 plus cot square theta is equal to cosec square theta.
Let me just write down the
Yes,
twelfth one
please.
first.
So these are the three identities in this exercise. Yes, Sarah, have you written?
Yes, ma'am.
Okay. Okay, Abdullah. So today I'm going to start the chapter that is some applications of trigonometry.
Ma'am,
Okay, ma'am.
Yes, Sarah.
ma'am, our the third exercise of trigonometry,
Hmm.
it's deleted, I think so, because our school didn't it.
Okay. So anyway, but that's an important exercise. You should know the relationship between complementary trigonometric ratios, right?
Yes, ma'am.
In knowing it. And obviously you will be using it in your higher classes as well. So just three relations were there, right? Let me just recall it for you. So one was that if you have sine of 90 minus of theta, then you get cos of theta, right? And the
Yeah.
second one is if you have, tan of 90 minus of theta, then you get cot of theta. And the cosec of 90 minus of theta will give you sec theta. So, I mean, you can just remember these three complementary relationships. That's it. Okay.
Yes, ma'am.
All right. Uh, so let us start a new chapter today. Yes, Martin, have you written?
No, I'm writing. I'm gonna finish.
You can take a picture of the screen if you wish.
Okay.
Mm.
Yeah, ma'am.
Okay. So that's your chapter number 9 now. So I thought let's continue with trigonometry only. We have just finished. So let us do this chapter, that some applications of trigonometry. So this chapter will give you insight into like where we use trigonometry in our daily life, right? So you will see a real life application of trigonometry. So it's all based upon whatever you have studied in the previous chapter. Now, before starting the chapter, you have to understand a few things, right? Now look here carefully, all three of you. There are three main terms which will be used in this chapter. One is called, okay, let me start with this situation. Let's say this is the ground, okay? Let's say this is the ground, right? And then a person is standing here, or let me draw a taller person. Let's say someone is standing here, okay? Right. Obviously on the ground, not in the air. Yeah. And then let's say there's a pole here. Anyway, this is a pole or something like this. Fine, Abdullah?
Yes, ma'am.
Okay. Now, this person is actually looking, let's say this is eyes, right? These are the eyes, let's say here. Now, if the person is looking at the top of the tower, so this is the line of sight, right?
Yeah.
Okay. So if the line which is actually drawn at the level of eyes, this is taken as the horizontal line or the horizontal. So you will come across this term in this chapter, the horizontal line, correct? Or horizontal level, we can say. This is the horizontal level. So the horizontal level will not be the ground. Understand this thing. The horizontal level is the level of the eye. Understood? First thing.
Yeah.
Okay, so this where the eyes are, so this is your horizontal level. And if the person is looking at the top here, so this is the line of sight. We call it the line of sight, right? This way person is looking. Now you can see in this picture, so there you have two lines. So obviously an angle is formed between these two lines, right?
Yeah.
This angle is called angle of
Depression.
elevation. This is the angle of elevation, correct? Okay. Now, if the person is looking at the ground, like the bottom of the pole, let's say this is the bottom. So this way, this is the line of sight this time. Understood? I mean, this is the line of sight. So this time, this angle is being formed with the horizontal level and the line of sight. So this particular angle will be called as angle of depression. Depression means, downwards, and when looking downward, it will be called depression. And when looking at the top, it will be called angle of elevation. So I hope you have understood these three terms.
Yeah.
Yes, Abdullah, Martin.
Yes, ma'am.
Okay. Okay. So it can be a situation like this. For example, I mean, this is a building, right? That's your balcony. Let's say your balcony, and someone is just standing at the balcony, right? And then there's a taller building, let's say something in front of you. It's another building, let's say. So you are looking from your balcony. So these are your eyes. So this is the horizontal level. Understood? This will be taken as the horizontal level. Now, if you are looking at the top of the building here, so this one is your angle of elevation, sorry. Fine, the angle of elevation. And if you look at the bottom of the building, then this will be the angle of depression which will be formed. So I think it's clear now.
Yes, ma'am.
Let's start with some questions. Exercise 9.1, you can open in your book.
Ma'am, should we write it like the angle which is below the horizontal level? It is angle of depression, and the above one is angle of elevation.
See, definitions will not be asked. Yeah, I mean, you can say, okay, if it is asked that what is angle of elevation, so you can write it is the angle formed between the horizontal level and the line of sight when looking at the top of the object or looking above the horizontal level, right?
Yes, ma'am.
See, this is the horizontal level, right? These are the eyes. So if you look above the horizontal level, so whatever angle is formed, it will be angle of elevation. If you look below the horizontal level, so whatever angle is formed, this will be angle of depression. That way you can define it.
Okay, ma'am.
Exercise 9.1. First question. Now see in the book, all of you. A circus artist is climbing a 20-meter long rope, which is tightly stretched and tied from the top of a vertical pole to the ground. So let's say this is any vertical pole, right? This is the ground. So you have to draw the picture first of all. I mean, whatever situation is given, you have to draw the diagram accordingly. And a rope is tied. So this is the top of the pole, and then somewhere on the ground, let's say this is a rope which is tied here like this. Understood?
Yes, ma'am.
Okay. 20-meter long rope. So this is given 20-meter long. Find the height of the pole. So you have to find this height of the pole. If the angle made by the rope with the ground level is 30 degrees. So this angle is given. This is 30 degrees. All right.
Yes, ma'am.
Okay.
Okay. So you can give some name to this triangle. Let's say PQR. Now it's very easy. You are interested in finding the height, right? If you take it as a triangle, so basically you know the hypotenuse in this case. All right.
Yes, ma'am.
Hypotenuse is 20 meter, which is given. And angle also, you know. So you can take a trigonometric ratio which actually involves perpendicular and hypotenuse, because you want to find the perpendicular, that is PQ, isn't it? So this
Yes, ma'am.
H is not the
Yeah.
hypotenuse, it's actually height. So write it height. Okay, so I'm interested in finding PQ. So if I take sine and sine of theta, now theta is already given, that is 30 degree here. Understood? So sine 30 is perpendicular upon hypotenuse, that you already know. So you can directly write sine theta is perpendicular is PQ and hypotenuse is PR. All right. Okay.
Yes, ma'am.
So you put the values. Now sine 30, this you already know, half, right? 0, half is equal to PQ you want to find, and PR is given, that is 20 meter. So you cross multiply. So 20 meter divided by 2 is equal to PQ, and 10 meter is equal to PQ. So you will write that the height of the pole is, obviously you will write in words. Hence, the height of the pole is 10 meters. So the question is not tough, right? Once you draw the diagram.
Yeah, ma'am.
Fine, Abdullah?
Yes, ma'am.
Okay. Let's look at the second question now. Written all of you?
Yes.
Yeah, ma'am.
Okay. Second question. Now read it carefully. A tree breaks due to storm. Okay. And the broken part bends so that the top of the tree touches the ground, making an angle 30 degree with it. For example, okay, let's draw the ground first of all. Let's say this is my ground, right? And there's a tree here. Let's say this is the height of the tree. So because of an storm, it break, like somewhere, let's say here, it has break. It breaks and it falls on the ground. So earlier, let's say it was the tall one. So this much part will actually come here now. Understood? Like this. So this way it has fallen on the ground. Please draw it with a scale properly. Right?
Yes, ma'am.
So
Yeah.
if I give it some name, for example, P, Q, R, and let's say this point is S. So basically your PQ is equal to QS, isn't it? Because this is the part of the tree which was actually standing. Now because of the storm, it has fallen down. So PQ is actually QS. Got the point here?
Yeah.
Yes, ma'am.
Okay. And making an angle 30 degree. So it has made an angle of 30 degree with the ground. The distance between the foot of the tree to the point where the top touches the ground is 8 meter. So from the foot of the tree and here, this distance is 8 meter is given. Find the height of the tree. All right. So height of the tree means, what is the height of the tree? First of all, tell me from in this diagram, how much is the
PR.
height? PR. Yes, height of the tree is actually PR. Okay. And PR is what? Is PQ plus QR, right?
Yes, ma'am.
Yeah.
Okay. How we will do it? Let me erase a little bit. Okay. See, now you want to find the height. That means you need the value of QR first of all, and also QS. You need to find QS also, because PQ is equal to QS. The height of the tree is PQ and plus QR, isn't it? So you need the value of PQ also. You need the value of QR also. So PQ we cannot find in this diagram, obviously, but PQ is actually equal to QS. So basically, I want to know how much is QS and how much is QR. Understood the problem here?
Yeah.
Okay. Now, if I want to find QR, first of all, and you look at the triangle. So in triangle QRS, right? You know base. Base, you know 8 meter. Fine. And you want to
Yeah.
find perpendicular. So which trigonometric ratio I should take now? Okay. Abdullah, which trigonometric ratio has base and perpendicular in it?
Base and perpendicular.
Tan 30.
Tan theta. Very good.
Tan.
Okay. So if I take tan of 30 degree here, tan is perpendicular upon base. So that means QR upon RS. All right.
Yeah.
Okay. Now tan 30 is how much? Tell me.
1 by
No, 1
root
by root
3.
3.
Okay. 1 by under root 3 is equal to, so QR I want to find, RS I know that is 8 meter. So from here, my QR becomes 8 upon under root 3 meter. Okay.
Yes.
Okay.
Okay. Now I want to find the value of QS also. Okay. So I can use like hypotenuse I want to find, right? QS is hypotenuse. So which trigonometric ratio has hypotenuse in it?
Then sin.
Sine. Okay, if I take sine, so sine is perpendicular upon hypotenuse. All right. And cos theta is base upon hypotenuse. So I can use any here because I already know the base, and a perpendicular also I have found here. So I can use sine theta also, I can use cos theta also, there is no problem. Fine, Abdullah? Right?
Yes, ma'am. Yeah.
Okay. So let me use sine now. If I take sine of 30 degree, sine 30 means I need perpendicular upon hypotenuse. So perpendicular is QR and hypotenuse is QS. Sine 30 is half. QR I have found 8 by under root 3 and then divided by QS. Or you write it like this directly to avoid confusion. So 8 upon under root 3 and then QS. Any problem?
No.
Yeah. So I want to find QS. So do cross multiplication. So QS will come here and then 8 into 2 and divided by under root 3, right? So this becomes 16 upon under root 3, right?
Yes, ma'am.
Okay. So the height of the tree is now height of the tree is equal to PQ plus QR, right? Now PQ is equal to QS plus QR, right? And QS I have found 16 by under root 3 and QR I have found 8 by under root 3, correct? So
Yes,
you
ma'am.
take LCM, that is under root 3 and you get 16 plus 8. All right. Please solve it. How much is this? 16 plus 8?
24
24. Okay.
by root 3.
By root 3. Okay. So I'm getting 24 by under root 3. So whenever you have under root 3 in the denominator, please make sure you have to rationalize it. Don't leave the answer here. Okay. So this is 24 by under root 3 and you do it under root 3 into under root 3. So you get 24 under root 3 and divided by 3. All right. And 3 into 8 is 24. So you get 8 under root 3. And in some questions, sometimes it is given that if under root 3 is equal to this, like value of under root 3 will be given. So let's say this is given in this question that under root 3 is actually 1.732, or you can remember this thing, you can write it down somewhere. This is the value of under root 3. Okay. So you do 8 into 1.732 and then multiply it, and whatever you get, that will be the answer. And obviously in meters. This is the height, which is it is in meters. Fine, Martin?
Yeah, ma'am.
Any problem, Sarah, Abdullah?
No,
No,
ma'am.
Please write it down.
ma'am, answer is 13.856.
Okay. So we don't leave under like square root in the denominator. So please remember this thing, okay? So rationalize it and then obtain the answer. So you can see I have got a nice looking answer here, 13.856 meters. Written, all of you?
Yes, ma'am.
Rationalize.
Yes, so we rationalize the denominator. Done?
Yeah,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Third question now. Okay, now read it. A contractor plans to install 2 slides for the children to play in a park. Okay. For the children below the age of 5 years, I mean little children, she prefers to have a slide whose top is at a height 1.5 meters. So a slide looks like this if this is the ground, right? So it is like this, right?
Yes, ma'am.
Okay. Whose top is at a height of 1.5 meters. So basically this side is given, that is 1.5 meter. So the top of the slide is this, and this is at a height of 1.5 meter from the ground and is inclined at an angle of 30 degrees. So this angle is also given, that is 30 degrees. Okay, whereas for elder children, she wants to have a steep slide. Steep slide means it is like more like this, okay? Like so the children will fall like quick, very fast. So it will be more height. So this is steep. Understood?
Yes, ma'am.
Okay. At a height of 3 meters. So now the top is at a height of 3 meter and inclined at an angle of 60 degrees. Obviously this angle is increased this time, right? Because the height is, so angle of elevation will be higher, right? From the ground. Okay. What
Yes.
should be the length of the slide in each case? So length of the slide means this one. So if I give some name ABC, so length of the slide is AC and this is, let's say, PQR. So length of the slide is PR, right? So you want to find AC and here you want to find PR, right? Now I want to find hypotenuse basically, and I know the value of perpendicular. Which sign ratio I should use here?
Sine.
Sine. Yes, Abdullah, which I should use? Perpendicular and hypotenuse. So which ratio I should use? Yes, Martin.
I'm sine.
Sine. Okay. So in triangle ABC, okay, always name the triangle, that which triangle you are using. In triangle ABC, sine of 30 degree will be perpendicular upon hypotenuse, that is AB upon AC, right? Now sine 30 is half, AB 1.5 meter, and AC you want to find. So this AC will become 2 into 1.5 meter, right? So AC will become 2 into, like, remove the decimal. So you have 10 here, and then 3, and then 2. So 2 cancel out, or 3 meters. So the length of the slide is 3 meter in this case, right?
Yes, ma'am.
And here, same thing you have to do in triangle PQR. This time your sine of 60 degree will be equal to perpendicular, that is PQ, and hypotenuse, that is PR. Now put the value 0/2, 1 upon root 2, root 3 by 2. This is root 3 by 2. PQ is 3 meter. PR you have to find, right? Do cross multiplication. So PR is 2 into 3 divided by under root 3 meters, right? Now you have under root 3 in the denominator, and sorry, PR. So this becomes, or you can write it, this 3 you can write under root 3 into under root 3, and then you have under root 3. Okay. So 1 under root 3 will cancel out. So it will be 2 under root 3 meters. And you can put the value of under root 3 if you wish. So 2 into 1.732 meters. So it will be 4, 6, 14, and then 3.464 meters.
Done, ma'am.
Okay. If it is not given in the question, the value of under root 3, you can leave the answer like here also, 2 root 3 meters. Okay.
Yes, ma'am.
Fourth question. The angle of elevation of the top of the tower from a point on the ground, which is 30 meter away from the foot of the tower, is 30 degree. I mean, first of all, draw a ground. Let's say this is my ground, right? And there is some tower here. Okay. Now the angle of elevation of the top of the tower from a point on the ground, which is 30 meter away from the foot. So there's a point on the ground which is 30 meter away from the foot of the tower. Okay. This is the point. Let's say A is the point. Is 30 degree. So from this point, the angle of elevation is 30 degree. Understood?
Yes, ma'am.
Okay. Find the height of the tower. So it's quite simple. So let's call it BC. You have to find the height, that is BC you have to find. So which ratio I have to use here? Tell me. Okay, Martin,
Tan.
you tell me.
Sorry.
Why tan?
Because having hypotonia, no, it's having perpendicular
Yes, and
and hypotonia.
Base and base.
perpendicular upon base. See, Sarah,
Yeah.
in this okay, in this question, what is given to me? This thing is base, right? So just forget about hypotenuse. I mean, I'm not interested in this side, right?
Yeah.
I'm interested in finding this side, BC. And I know the value of base. So I'll use a ratio which has perpendicular and base in it. So don't include hypotenuse here. Okay. So use tan 30 is perpendicular upon base. That means BC upon AC. Clear? So that means 1 upon under root 3 is BC upon 30 meter. So BC will become 30 divided by under root 3. You can rationalize it. That is 30 upon under root 3. So into under root 3 into under root
Ma'am,
3. Yes.
this is in triangle BCA or ABC.
ABC, yeah, obviously, because I have only forgot to write. ABC, I mean, it's name. You can start from whichever corner you want. ABC, BCA, CAB, anything you can write. Because I'm not doing similarity here, right?
Yes, ma'am.
Okay. Okay, Martin?
Yes, ma'am.
Yeah. So you have to rationalize it. So this will become 30 root 3 divided by 3. Clear? And then 30
Yeah.
divided by 3 is 10. So 10 root 3 meter is the answer, PC. Or you can write then height of the tower is 10 root 3 meter. So always conclude with a line. Abdullah, I can't hear you.
Yeah, ma'am. What?
Okay, you are here in the class.
Yes, ma'am.
Okay. So next question now, fifth one. Have you written all of you?
Yeah.
Yeah, ma'am.
Fifth question. A kite is flying at a height of 60 meter above the ground. So there's a ground, let's say, right? This is a ground. So a kite is flying at a height of 60 meter above the ground. So there's a kite here. Let's say you have a kite here looking like this. So the height of this kite from the ground is actually 60 meter. All right. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. So the string, it flies with a string. So the string is actually tied somewhere on the ground. And this angle is 60 degree. Okay. It's quite
Yeah, ma'am.
obvious. For example, you're flying a kite, right? And let's say you are standing here. The kite doesn't fly like this, right? Yes, Martin?
Yeah.
It never flies like this. It always go either this side or this side. I mean, always at an angle it flies. So the string is actually tied here at this point, and this is the string with which the kite is attached. Find the length of the string. So you have to find this. If I give it some name, let's say AB. So I want to find AB. Clear? Assuming that there is no slack in the string. I mean, the string is not like this. Sometimes the string flies in the air like this. So we are assuming that the string is straight. Okay.
Yes, ma'am.
Okay. So again, I know the height this time. That means perpendicular. And I'm interested in hypotenuse. Which ratio I have to use? Tell me.
Sine.
Sine. Okay, very good. So sine of 60 degree is perpendicular by hypotenuse. Let me call it C. So BC divided by AB. Clear? Now sine 60 is root 3 by 2. And this is 60 degree. So, sorry, 60 meter. AB I want to find. So my AB becomes cross multiply. So 2 into 60 and divided by under root 3 meters. Clear? So you can see I have under root in the denominator. So you rationalize it. AB is equal to 2 into 60 divided by under root 3. So into under root 3 into under root 3. Clear?
Yes, ma'am.
That becomes 2 into 60 into under root 3 and divided by 3. So that becomes 2 into 20 into under root 3. So that becomes 40 into under root 3 meters. Right?
Yeah.
So you can write the length of the string is 40 root 3 meters. And whenever you are mentioning length, so always write units. Don't forget to write it. Yes, have you written?
Yeah.
Yeah.
Okay. Now look at the next problem. A 1.5 meter tall boy is standing at some distance from a 30-meter tall building. See, first thing is you always draw your ground. That makes things a bit simpler. Okay. Let's say this is my ground. So you write, this is your ground level. Now the boy is 1.5 meter tall. So a boy who is standing, let's say, right, whatever he is a boy. So this is 1.5 meter. All right, this height is standing at some distance from a 30-meter tall building. And then you have a building. So building is also going to be on the ground, isn't it? Right?
Yeah.
Okay. So this building is 30 meter in height. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. So, okay, so first he is standing here and this is the level of eye. So you will draw the horizontal level first of all. Understood, Abdullah? So this is your horizontal level. Clear? Now, from here, when he is looking at the building, so this is the line of sight. Understood? So this is the angle of elevation. Now, earlier, this angle of elevation was 30 degree. Now he is moving towards the building. Read the sentence again. The angle of elevation from his eyes to the top of the building increases from 30 to 60 as he walks towards the building. So let's say he is coming here. From here he is watching. So now the angle of elevation has become 60 degree. Understood?
Yeah.
Yeah.
Okay. Find the distance he walked towards the building. So I'm interested in this distance. I mean this red one. Understood?
Yeah, ma'am.
Yeah.
So let me give it some names. First of all, let me call it A, B, right? C, D, and E, and F also, I can say, right? Okay. Now you can see I have 30 degree angle and 60 degree angle. So basically two triangles I can take. So I cannot take AEC because to apply trigonometry, I need a right angled triangle. Clear?
Yeah.
So if I'm taking 30 degree angle, I have to take the triangle AED. See in the figure. AED.
Yeah,
Right,
ma'am.
Abdullah? Okay. And if I'm taking the 60 degree angle, I'll take the triangle CED. Okay. Now I want to find AC, right? Now AC, how can I find AC? If I find the complete length AD and then I subtract this length CD. So I get AC, clear?
Yes, ma'am.
So first of all, I'll take this triangle AED in triangle AED. So I'll use this 30 degree angle and I'll find AD. That means the base I'll find. So I want to find base and I know the value of perpendicular. So do I have the value of perpendicular here?
No. Wait. Yeah. It's 30.
30. Okay. Yes. What about you, Abdullah? How much is
Yes.
my perpendicular here? What is the length of my perpendicular in this diagram? If I'm taking triangle AED, I want to use this 30 degree angle in some trigonometric ratio. And I want to find base AD, right? So how
Yes.
much is the length of my perpendicular?
30.
30. Yes, what about you, Sarah?
30 meters.
30. All three are wrong. Look very carefully. I'm taking triangle ADE. That means only this much length I need. Only this much. And 30 degrees is the total height of the building, isn't it? From the ground. The building is not standing in the air. It is reaching till F, isn't it? On the ground.
Oh.
So I need to find ED first of all. Clear?
Yes.
Yeah. So you find ED first of all. ED is actually your complete length EF and minus DF, isn't it? Now DF is same
Yeah.
as AB, right? Because this is ground and this is horizontal level, both are parallel lines. So it's actually EF and minus your AB, which is given. So 30 degree minus, 30 meter minus 1.5 meter. And this will come out to be how much? 28.5 meter, right? That's my
Yes,
ED. So I'll use perpendicular and base. So that means I can use tan here, right? Tan of 30 degree. But now perpendicular is ED and my base is AD. Clear?
Yeah.
So tan 30, that means 1 upon root
Yeah.
3. ED is now 28.5 meter and divided by AD I want to find, right? Okay. Yes, Harsha, are you there in the class? Let me just complete this question. Okay.
Okay, ma'am.
Right. Now do cross multiplication. So your AD will be under root 3 into 28.5 meter. Clear? Or you can write it like this, 28.5 under root 3 meters. So that's your AD, right? Okay. Now
Okay.
come to another triangle. So in triangle ECD, clear? ECD. Again, I can use tan 60. So tan is perpendicular upon base. Perpendicular is ED, base is CD. Clear?
Yes.
Okay.
Yeah, ma'am.
Tan 60 is under root 3. ED is again 28.5 meter and CD I want to find. So from here your CD will be 28.5 and yeah, divided by under root 3 this time, right? So you can rationalize it. It will be 28.5 under root 3 divided by 3, right? So multiply both numerator and denominator by under root 3 under root 3. So the denominator will become 3. Clear? Okay. Now this much is fine. You have found AD and you have found CD. Now I want to know AC. So now my AC is actually complete length AD minus CD, right?
Yes,
Yeah.
ma'am.
Okay. So now be careful with your calculations. So AD, how much I have found AD? Where's my AD? Yeah, 28.5 under root 3 minus 28.5 under root 3 divided by 3. Clear?
Yeah.
Okay.
Yeah.
So you can solve it like this. Like you can take 28.5 common or under root 3 in fact common. So you will be left with 1 minus 1 upon 3, right? So
Yeah.
I'm
Yes,
using
ma'am.
this as space. So it will be 28.5 under root 3 and then you take LCM. LCM will be 3. It will be 3 minus 1, that is 2. So 2 by 3. Clear? Okay. Now you can check 28.5 is it divisible by 3? 3 into 3, yes, I think. See, 3 into 9 is 27 and then you get 15. So 9.5 under root 3 and then you have 2 here. So you multiply this. So 2 into 5 is 0. Carry 1. 2 into 9 is 18 and 1 19. So it is 19.0 into under root 3 meters. So 19 under root 3 meters is the length of AC. Please write it down quickly. I have another class now.
Sir, 19.0.
You have multiplied 9.5 with 2, right?
Yeah.
Do it separately. 9.5 with 2. Multiply it. 2 into 5 is 0. Carry 1. 2 into 9 is 18 and
Oh.
1 19. So it will become 19.0. I've multiplied it directly here.
Can you tell us the marks?
Sorry.
Maths.
Marks, yeah, I'll send you.
Okay, ma'am. Ma'am, I'm done. Can I leave?
Okay, yes, you can leave now.
Thank you.
Thank you, ma'am.
Okay, bye. All right, Hamna, Rida, Harsha, you're here. Yes, Rida, am I audible?
Yes.
Okay, Hamna. Okay, first of all, I'm going to start the new chapter, but before that, I want to discuss a few things about the test. Right? Okay, Harsha, can you hear me?
Yes, ma'am.
All right. So first of all, it was my mistake. There was error in 2 questions. So I'm not evaluating those 2 questions. It was some writing mistake from my side. The one is question number 4. So what I gave you is 5 sine theta minus of 3 cos theta and then divided by 5 sine theta and minus of 3 cos theta, right? So I actually wrote minus both numerator and denominator. So answer should be 1 with that logic, right? It was supposed to be plus here, but I gave minus, so it was my mistake.
Ma'am,
And
is the 4th question?
yes, 4th question. Yeah, 4th question, basically it was given that 3 cot theta is equal to 4, then find the value of this thing, right?
Okay, ma'am.
Yeah. And then 10th question also, I don't know why I did this. So it was sine theta minus, 2 sine square A and then divided by